what I would say one of the top concerns right now from an MMOD perspective is the huge uncertainty in the models, in the orbital debris models, and the lack of direct data from most of the orbital altitudes around the Earth that would help improve the models or validate the models. The majority, well, almost all of the direct measurement type data we have comes from looking at damage to the shuttle or damage to satellites that were returned to Earth from the shuttle. So that means that encompasses a regime where the shuttle flew around 400 to 600 kilometers. So when they formulate the models, the orbital debris environment models, they have to extrapolate beyond where they have that real data. And when we have compared different orbital debris models in the past, they vary widely at those upper models. They all agree that the debris environment is worse at those higher altitudes. You have more spacecraft up there. So one of the primary concerns and objectives would be to get direct measurement data, would be to get satellites that have sensors that are able to detect impacts and relay that information back down so that these models can be validated and they can be improved, and we can see how well we really are doing at predicting risks. Because right now, all the risk numbers that we produce are full of uncertainties because of the uncertainties in the model. And there's other uncertainties also that go into it. So I think that's, for me, the primary issue right now is trying to bring down some of these uncertainties in the risk assessment process. The models that we have now are based on two types of data. There's impact data from impacts on the shuttle and another spacecraft, and the size of the particles for those impacts usually goes up to around 1 millimeter in diameter. And then we have radar data. And radar data, we can track radar, we can track objects to about 10 centimeters or so, but we can detect objects down to around, I think it's around 3 millimeters, depending on the orbit. And so we can get data on the population of orbital debris for the larger objects, but that leaves a gap at 1 millimeter to 3 to 5 millimeter region that we have to extrapolate, and we don't really know. We don't have any direct measurement data. If we had either a dedicated spacecraft or an experiment that might piggyback on a science spacecraft that goes up to around maybe 700 to 800 kilometers orbital altitude, that's where we really see the peak in orbital debris, and measure. You can create an impact sensor that can give you the direction that the impact occurred, obviously a count of how many impacts, and the larger surface area the better, because you're going to collect more, and relay that information down. That would give us some direct measurement information in an altitude which is very important, and we don't have any data right now.